Okay, so our 6 trig functions are sine, cosine, and tangent, cosecant, secant, and cotangent. Oh, I didn't finish spelling cotangent, did I? There we go, cotangent. But the 3 that we are studying this year are just sine, cosine, and tangent. We abbreviate those SIN for sine, COS for cosine, and TAN for tangent. Now, these are very helpful because they can help us find missing sides and missing angles of any kind of right triangle. Doesn't have to be 30, 60, 90. Doesn't have to be 45, 45, 90. We can have any angles of a right triangle. Now, on this first one, what we have is this new symbol right here. This is a Greek symbol. Does anybody know the name of that Greek symbol?
0.
It does kind of look like 0 with a little tilde through it.
No.
It's actually called theta.
Oh, my second.
And theta is a Greek symbol that's used to represent angles a lot in mathematics. So your teachers may start using a theta. They may use x. They may not use a theta. They might label your triangles A, B, and C and not use the theta, but you're going to start seeing the theta. And that's just a way to represent an angle in mathematics. So what we're going to do is we're going to take a look at this right triangle, and with regards to theta, this angle right here, which side is the opposite, which side is the adjacent, and which side is the hypotenuse? Well, the hypotenuse is always the easiest because the right angle always points to it. So this one would have to be the hypotenuse.
Oh, wait. One more other one, like the one all the way to the right. It's hypotenuse.
We're going to get to that one. It's right here.
Yeah.
Yeah.
But you can have it as a hypotenuse too, because it points at it.
Yes. This is the hypotenuse on that one. It points to it.
I thought it was like 3 different ones.
Nope, there's always just one hypotenuse. And the hypotenuse is always the longest side of a right triangle.
Okay.
Okay, now, let's get back to this first one. Here's my theta. Do you see that this side is across from this angle? It is opposite that angle. So we would label this one O for opposite. H for hypotenuse, and we're going to do A for adjacent. Adjacent is the side that is not the hypotenuse that attaches to the angle. So do you see this is my angle, this side is not the hypotenuse and it attaches to my angle. It's called the adjacent side. Adjacent means right next to. Okay, so now we've labeled them opposite, adjacent, hypotenuse. Let's take a look at the next one. Okay, first thing we're going to do, the right angle always points to our hypotenuse, so it's got to be down here on the bottom. Now, if you don't like it when the hypotenuse isn't on the side, just take your paper and rotate it. Make it look the way you want to, so you can see it real easy. All right, here's my angle right here. Here's theta. So across from theta is the opposite side. Across from theta, this is my opposite. And so the side that attaches to the angle is my adjacent. Okay, you try the last one. We got a head start because we've already labeled the hypotenuse, which is the easiest one. Okay, this side over here is across, so it would be the opposite, and this side is the adjacent. Okay, now we're going to look at our 3 trig functions, or the ratios that we're going to study in analytic geometry. So a ratio just means a fraction, right? Okay, so sine is just the ratio of the opposite side to the hypotenuse. And I just usually say O over H to abbreviate. All right, cosine is a ratio of the adjacent side to the hypotenuse.
A over H.
That's right. And tangent is a ratio of the opposite side to the
Adjacent.
adjacent side. So we say O over A. Okay, I'm going to give myself a little more room over here because I want to show you the mnemonic that we use in math to help us remember. It's called SOHCAHTOA. SOHCAHTOA. Okay, so a mnemonic is a little memory device that helps us remember things that don't come naturally. Okay, so math teachers make up silly little stories about this great Indian chief called Chief SOHCAHTOA. And he was a great mathematician and Indian chief. And one year I did that when I taught at a different school. And then I had my students chant, SOHCAHTOA, SOHCAHTOA, because I told him. Anyway, we were evoking the spirit of Chief SOHCAHTOA so we could do our math problems. I really thought I was being silly, but I was hoping it would help everyone remember. And then at the end of class, this poor sweet child came up to me and she said, Miss Willoughby, I'm afraid I can't do these problems. Evoking spirits is against my religion. I was just being silly. There is no real spirits, Chief SOHCAHTOA. So since then, we don't chant SOHCAHTOA. But hopefully, SOHCAHTOA will help you remember. So what I'd like you to do is at the top of every paper you get, write SOHCAHTOA. Why is it helpful? Because it tells us that sine is opposite over hypotenuse. That cosine is adjacent over hypotenuse. And that tangent is opposite over adjacent. Yes? Yes.
Did you try something like this?
Uh-huh.
It's like, you called me?
We are reviewing today and tomorrow because I'm not here tomorrow.
I am.
But, sure, that'd be great. That'd be awesome. Okay, thanks. Okay, so that's how it helps us. So sine is opposite over adjacent. No, it isn't. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent.
Oh, I get it.
So it helps us to remember what these ratios are. SOHCAHTOA, SOHCAHTOA. There's no real Indian chief. We're not evoking any spirits. Okay. We're just hoping that this helps us remember.
Does that make you?
Are we ever going to be able to like have drinks in this class again?
No.
Because I really want coffee. What if I'm careful?
Just get up earlier. Okay.
Or just shut it down. It's like tiring.
All right. So we're gonna baby step our way into how we use this, and then when we get to the application, guys, you're really gonna see how it's actually used in the real world. If you guys have ever seen surveyors on the side of the road, measuring distances from far away, what they're using is trig. Now, the methods that they do are a little more advanced than they once were. but the calculations are done using trig.
I saw.
So we're going to get into that, but we're going to baby step our way into that. So SOHCAHTOA is what we're going to write at the top of every page, and since I started a new page, I went ahead and wrote it. Alright, so they're asking us to find these ratios. What is sine of theta, cosine of theta, and tangent of theta? So the first thing we do is we find our theta, and then we label our sides. This side is across from it, so it's the opposite. This side is across from the right angle, so it's the hypotenuse. And this side is attached to it, so it has to be the adjacent. Now, do you notice that we're missing this side right here? You do. Okay, this is one of the Pythagorean triples. Do you guys remember this one? This is a 5, 12. Anybody? Let's find it then. 5 squared plus 12 squared equals the hypotenuse squared. So 25 plus 144 is 169. What is the square root of 169? 13. So this is a 5, 12, 13. So if you're ever missing a side, you can always do the Pythagorean theorem to find it. Alright, so we have 5, 12, 13. And then they ask us to find these ratios. Now, they're not asking us to find theta. They're just asking us to find sine of theta, cosine of theta, and tangent of theta. So we go back to old SOHCAHTOA. Sine is the ratio of the opposite to the hypotenuse. The opposite is labeled 12, and the hypotenuse is 13. That's all there is to it.
Pretty easy.
Cosine of theta is a ratio adjacent to hypotenuse. So the adjacent side is 5. The hypotenuse is 13. And then tangent of theta is a ratio of the opposite to the adjacent. The opposite side is 12. The adjacent side is 5. Okay, you try number 5. So first of all, you have to find that missing side. And I can tell I did not draw this triangle to scale. That missing side is actually going to be bigger than 3. I did not draw that to scale. So don't let that confuse you. So find that missing side and see if you can come up with those ratios.
Do we do 6 and 7 too?
6 and 7, you're going to need calculators, and mine aren't out right now.
So can we use our phones?
That might be good. Okay, did you guys get that the missing side is 4? Mm-hmm. Okay, so if this is my angle right here, this one is across from it, so it makes it the opposite. Here's my right angle, so this one has to be the hypotenuse. So what does it leave for this side? The adjacent. And it is attached to the angle, so that makes sense. So now let's do sine, cosine, tangent. Sine of the angle is the opposite over the hypotenuse. So in this case, it is 4 over 5. Opposite opposite over hypotenuse. Sine, opposite over hypotenuse. Okay. Cosine of theta.
3 over
Cos,
5.
adjacent over hypotenuse. Adjacent is 3. Over hypotenuse is
5.
5. Tangent is opposite over adjacent. So opposite side is 4. Adjacent side is
3.
3.
Slowly.
Yes.
How do you get 4?
That's what I wonder.
Oh, okay. So I did side squared plus side squared equals hypotenuse squared.
Oh, okay, I did it wrong.
That's what I did, but I got 16. I don't know.
You just didn't take the square root. You're so close. 16 is right.
Excuse me, that's a 40.
It's a 4 is the opposite side.
Yeah, yeah.
Oh,
Yeah.
4 is
I
the
understood.
opposite side. Sorry. Oh, you were just helping me understand.
Yeah.
Thank you. Thank you for helping me understand. Okay. Okay, so is this the angle I labeled theta on yours, or is this?
Yeah.
This one?
That's one.
Okay.
Yeah.
And which one did I do here? This one?
Yeah.
Okay. All right. I forgot to do it on the computer, but I did check it out before I got to the printer. Okay. So this is the side we're missing. Is this a leg or a hypotenuse here?
That is a leg.
Okay. So if we were to do Pythagorean theorem, we'd say 8.1 squared plus b squared equals 11.4 squared. So when we do 11.4 squared,
8.0.
y'all get 129.96.
Yes. And subtract that by
And then we do 8.1 squared.
65.6.
Good.
subtract it,
Yeah, and that's what we do next, is subtract it.
which would be 64.35, and then you take the square root. It comes up with a pretty meh number.
Oops, let me go back to the other color. So we get, come on. So we get b squared is exactly 64.35. And then when we take the square root, we're going to get an approximate here.
8.021.
8.02.
Mm-hmm.
So that would be, if we were just doing to the 10th place, wouldn't that just be 8.0?
Yep.
All right. So that's how we find a missing side, Pythagorean theorem. All right, so here's my angle. This one is across from it. Would I label this opposite, adjacent, or hypotenuse? Opposites. Okay, here's my right angle. It always points to the hypotenuse. And so that means this one is the adjacent. So we'd say sine of theta is SOHCAHTOA. Sine is opposite over hypotenuse. So it'd be 8.0 over 11.4. Cosine of theta, adjacent over hypotenuse. 8.1 over 11.4. And the last one, tangent, opposite over adjacent. So it would be
8.0.
8.0 over
8.1.
8.1. Now, usually we don't leave decimals and fractions, but it's okay on this problem. Okay, do you guys think you can try number 7? All right, we're missing the hypotenuse on this one. So think about how you set up a squared plus b squared equals c squared. And just round that answer to the 10th place.
you doing, bud?
All right.
So this is going to end up being.
Huh?
It ends up being.
When you, when I turned it off.
Oh no, I wanted you to just round this. Sorry. Okay, so let's do a quick check step. Did you get 5.6 for the hypotenuse? Okay, the hypotenuse should be 5.6. So when you did 3.2 squared plus 4.6 squared equals c squared, here we should have gotten 31.4 equals c squared. So 5.6 is approximately equal to c, or the hypotenuse. Okay, so there's check step number 1. If you didn't get that, write this down and now label opposite, adjacent, and hypotenuse. Okay, so let's do another check step. This is our hypotenuse. This is our opposite side. This is our adjacent side. Did you label opposite, adjacent, and hypotenuse?
It is.
Okay, now set up your 3 ratios. Sine of theta, cosine of theta, and tangent of theta. Okay, I have them right here for you. Now I use the actual fraction bar, and here I use the slash. It means the same thing. I was just running out of space. Yes, sir.
Can I have
Sure. Okay, any questions so far? Right, so we have SOHCAHTOA. That's our mnemonic to help us remember. Sine is a ratio of the opposite to the hypotenuse. Cosine, adjacent to hypotenuse. Tangent, opposite to adjacent. SOHCAHTOA, SOHCAHTOA. That goes at the top of every page. So let's take a look at these last 3 at the bottom here. And once again, I'm going to write, because I can't see it anymore, I'm going to write SOHCAHTOA. Sine, cosine, tangent. SOHCAHTOA. Alright, here, it says to sketch a triangle that has theta as one of its acute angles. Let's revisit. What does the word acute mean?
Less than 90.
Good, less than 90. So, it can't be the right angle, but one of the other 2 angles. And then find the values of the other 2 trig ratios, we could say functions or ratios, covered in this unit. So if I give you sine, then you find cosine and tangent. If I give you tangent, you find sine and cosine. If I give you cosine, you find sine and tangent. All right, so the first thing we do in math is draw a picture when we don't have one. That helps us to visualize what's going on. So any kind of right triangle, y'all usually don't draw them upside down, so let me twist mine around. There we go. Good enough. And we get to pick a theta. I get to choose which one of these acute angles is going to be my theta. I picked this one.
So those 3 and 5.
Okay, so now we are going to label our sides. From this theta, this side is the opposite, this side is the adjacent, this side is the hypotenuse. Does that make sense, labeling the triangle? Okay, well sine is opposite over hypotenuse. So 3 has to be the opposite, and 5 is the hypotenuse. So we're going to do that. We're going to go, okay, The opposite is 3. The hypotenuse is 5. This is one of those Pythagorean triples. 3 something 5 right triangle. What's the missing side?
4.
4. Now we could do Pythagorean theorem and get the 4 also. It's a 3, 4, 5 right triangle.
How'd you figure out the 4?
It's one of those Pythagorean triples. So if you notice that, the 3, 4, 5, you can just write the 4. If you don't notice that,
Oh, you just
what
did Pythagorean theorem, okay.
what we do is Pythagorean
Yeah,
theorem.
yeah, okay. Thank you.
Okay, so what are the other two? There's sine, so I need cosine and I need tangent. I need cosine and tangent. It doesn't want to change from green. All right, cosine of theta is going to be comp, adjacent over hypotenuse. Which side is the adjacent?
4,
4 over 5.
Oh.
Okay? Tangent of theta. Tangent, opposite over adjacent. Which side is the opposite? 3 over 4.
One question.
Yes.
When we draw in the triangle, where can we put the theta? Anywhere?
It can be either of the acute angles. So it could be
Okay.
here, it could be there. It just can't be the right angle.
Okay. The way to put it, it's up to you, right?
It sure is.
Okay.
Okay, the next one says tangent of theta. So I'm going to draw my right triangle here. And I know tangent is opposite over adjacent. So this is my opposite side, that is my adjacent side. I'm going to choose to put theta right here. My opposite side is 1. So this opposite side right here, the opposite side is 1. The adjacent side, which is right here, would be 2. Pythagorean theorem will help me find that third side. So 2 squared plus 1 squared equals hypotenuse squared. 4 plus 1 is 5. So the hypotenuse is the square root of 5. Guys, whenever they ask you for an exact, when you see the word exact, that means don't punch it in your calculator and get a decimal. A decimal is approximate. So whenever your directions say exact, you're going to leave it like this. And so we're going to practice doing exact here. So we're going to leave it square root of 5 as our hypotenuse.
But then we have to change it because the square root cannot be.
Right? It's going to take a little work. So we've got tangent. So what we need are sine and cosine. I'm running out of space, so I'm going to steal some from down here. So now we need sine and we need cosine. Well, sine is opposite over hypotenuse. So the opposite is 1 and the hypotenuse is square root of 5. Row.
And with the, you have to multiply by square root of 5 to get 1.
Yes.
One
So we can't leave that radical in the denominator. You guys are so on it. You have to multiply by the square root of 5 over the square root of 5. So this is the square root of 5 over 5. And the same thing happens with cosine. Cosine ends up being 2 over the square root of 5. 5.
It'll be. And you do the same thing.
You do.
And you
Good. So we multiply by the square root of 5 over the square root of 5. So it's 2 roots of 5 over 5.
Nada.
So we just leave it.
Yeah, we're done.
Is that enough practice for this kind?
Yeah.
Okay, let's skip. We're going to skip it. Skip number 10. Let's move to the back.
Boy.
Is that back?
Okay, now, guys, let me go ahead and tell you. That is all you're covering in class today. That's it for your class today. But because I'm at county office tomorrow, I won't be here.
See?
I would like to go ahead and talk about what you're going to see tomorrow. I like to give you a little extra information ahead of time. That way, hopefully, does it make it easier when it goes fast in class if I have gone slow in here? Good. That's my goal, is to make class a little bit easier. Now, in here, we focus on, most of the time, the kind of basic problems. Have y'all noticed that? And then in class, you get a chance to work on some of the more difficult ones. So I'm going to show you some basic ones on the back. Now, do I expect you to 100% have it when you walk out the door today? Nope. We've got a couple days for this to all soak in and make sense to us.
But then we
Okay.
have a break to get that and eat.
Huh?
Then we have a break called Thanksgiving where we have an excuse to eat.
Yes, we are getting,
Yes.
yes, that is in my plan. Alright. So, do you guys see, this triangle is labeled A, B, C. So C is our right angle. So there's actually two ways we can set up sine, cosine, and tangent. And we're going to do that real quick. We're going to look at everything from angle A. So this is another way we can name it. And then we're going to stick with the same triangle and we're going to look at everything from angle
B.
B.
Oh, okay. So
We're going to look at it from both perspectives on this one. A and B. And then we're going to compare something and see if we notice anything kind of cool. All right. Now, in geometry, when you label a triangle, the side across from angle A could be labeled little side A. The side across from angle B can be labeled little side B. The side across from angle C can be labeled little side C. So the lowercase letters is one way to name your sides. It's always the lowercase across from the angle. Now, first thing we're going to do is label all of this with respect to angle A. So with respect to angle A, this one is the
opposite.
opposite.
Here's the
This
adjacent.
one is the adjacent, and this is always the hypotenuse.
See?
Okay, so sine, I did not write it. SOHCAHTOA, SOHCAHTOA.
You cold?
What now?
I'm trying to get it stuck in my mind.
That's what I thought I heard.
So good.
All right, so sine is a ratio of the opposite to the hypotenuse. Well, in this case, the opposite is just labeled little a. And the hypotenuse is labeled little c. Cosine of A is the adjacent to the hypotenuse. So that's going to be little b to little c. And tangent of A is opposite
A, B.
over adjacent. Now, when we look from angle B, something interesting happens. From angle B, this is not the adjacent. It is now the opposite. And this is not the opposite. It is now the adjacent. So, sine of B is B over
C.
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 Cosine of B is A over C.
B, C.
And tangent is B over A. I meant to do these in pink and I did not do that, so let's see if I can make them shrink.
Yeah.
I did. So. Okay, now, cool thing right here. Do you guys see that those two are the same?
And so is the C.
And do you see that these two are the same?
and
So
tangent.
sine of A is the same as cosine of B. And cosine of B is the same as sine of A. Well, cosine of A is the same as sine of B. And sine of B is the same as cosine of A. And this always works, guys. A and B have to add up to how many degrees?
90.
90. Because they are complementary. All three angles of a triangle have to add up to 180. And since this is already 90, those two also have to add up to 90. They are complementary. So to find sine of any angle, it's the same as cosine of its complement. 90 minus that angle would be the complement. And cosine of any angle is the same as sine of its complement, 90 minus that angle.
So for number 9, it would
So
be
sine of 30 is the same as cosine of 90 minus 30. What is 90 minus 30?
60.
60.
Well, that's easy.
Cosine of 80 would be the same as sine of what? 10. 90 minus 80. And we can see it's true from up here. It has to work. So sine of x is going to be the same as cosine of 90 minus x.
Because you can't do anything with the x.
So let's see if you have it. Sine of 20 is the same as cosine of what? 70. You got it. Okay. Cosine of 50 is the same as sine of 40. They're equivalent.
It's just simple
Okay.
subtraction.
Now, those of you that have a calculator or have your phone, take those out and let's prove it. Punch in sine of 40 and then punch in cosine of 50. And let's see what the decimal equivalent for that ratio actually is. Okay, so either use your phone or use a calculator.
Cosine 30.
Then the 40 is cosine of.
No, 90 is 40.
Is there anyone in here that needs a calculator? Do you have one? Okay.
Cosine.
Do you have the phone? Awesome. Awesome.
Oh, I got the same. I got the same thing.
Yes.
One thing
All right.
right here.
We can make sure yours is going to be 41 plus.
That's good.
My best friend. See? Who is Drew Moyfield? Drew Moyfield.
Hey guys,
See?
any of you that have those awesome graphing calculators, what you have to do is you have to put your calculator in degree mode. Yes.
I got a decimal for each one.
Shrek is not there. It's like, hey Elizabeth.
Okay, so let me talk about two things. If you're using your phone, you have to punch the 40 in first. So you do 40 and then sine and then 50 and cosine. And you'll see you get 0.64 or something for both of them.
Well,
They are the same. Now, what I'm going to do is I'm going to take just the basic graphing calculators back out.
Wait, you mean these ones or the other
Yeah,
one?
yeah. For you guys to use tomorrow. If you have one of the fancy graphing calculators, though, you have to make sure you put it in degree mode. Is there anybody that...
Good morning, Starsville. This is Ellie. Your morning announcements are ready to be viewed from the website. Thank you and make it a great day.
Okay, I am not done with today's lesson. So, guys, what that means is the beginning of class tomorrow, you're going to get to watch a video of me teaching. Okay? Yes, it's awesome. So what I'm going to do during my planning period today is I'm going to make a short video where I go over the last 4 problems on this page in detail. I'm going to go really slow, and I'm going to try to think of every question you might have and answer it in my video. Okay? So you're going to watch that video first tomorrow, and then what I'm leaving you are little 2 different practice sheets that are puzzles, so they have the answers there. When I'm not here, I always count your work for more, because some of my students in the past, when I'm not here, they choose to do nothing. And so if I give the assignment a higher point value, then my students tend to practice. The practice for what we're doing right now is really important. It'll help you do much better on your test next week. So tomorrow, first thing, video, then practice problems. Okay, so save this worksheet you did today for that.